Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my WaterJet series. We have a little bit more news with pricing of how much value that this WaterJet's actually going to bring. So it's looking like it's going to be about that $50 mark plus shipping, so $65 mark or so per shredder. So let's see, how long would that take? So about $2,000. $2,000 divided by 65. It's 30 shredders divided by 2 per week. It's actually like 2.5 per week, so that's about 15 weeks divided by 4.4. That's about 3.5 months to pay it off, and then the rest of the time it's pretty much good to go. So I have yet to talk to these guys again about the hosing. I do have it saved here, so because I've been so busy trying to get these shredders off the ground and ordered. So I have been looking at getting them ordered from these guys, and I need to go through, and tomorrow, while I'm calling these guys, I need to go in and or basically the next time that I what's the word I'm looking for? I think tomorrow during the day, I'm gonna have to go online and I have to modify some of these files here for the shredder because I want to make it a little bit better as far as cutting, especially on this machine. For example, with these guys, where's a regular spacer? 7/24/18. A while from now. It was a year from now. So, actually, is that exactly a year? A year and 5 days since I last saved this. Oh, there's a new one. It's from 2017. Anyways, so this could actually be a circle here. That way, it doesn't have to be super perfect tolerance and fit on the shredder itself, or even like a elliptical shape like this. It's probably just going to be a circle, and then these points on the actual machine itself are going to be filed down, so that, because again on here the machine can't actually do square corners, but on the circle it's going to be an entire circle here. So I think it should be all right. Go here. Ooh, it's 1/10 of an inch. 1/10 of an inch. That is not a lot, but that's okay. I mean, again, there's going to be no stresses here. Pretty much everything, all that this is doing is to hold this together. But again, this is going to be a circle here, so let's look at that. So maybe I should go in and see exactly how much space we have here. And again, this is outdated because these are now in a little bit, but that's okay. Project and project. Okay, so obviously it's in a little bit, so we need just a little bit of clearance. Oh. It's a little bit under, but what we actually had to look at is that in actuality it is sort of rounded. Okay, so yeah, so we can't really add any more height to that. So maybe it'll have to be some sort of so I really don't know how much stability this is going to add, right? This is 1.31. It might add some stability. But it'll definitely be way easier to manufacture because you just run. And then if this doesn't fit on the shredder, it's okay because you just, right here is definitely going to fit. And there's no change in direction, so once it starts in here, it has a lead in and it just rips around. Because again, on each shredder there's 24 of these, so if like 5 or 6 of them are out of tolerance, then we have an issue. So that's one thing. Another thing is I could really bump up the tolerance. I think that that's also fine, is just to bump up the tolerance and tell them to just zip through it. Because really, you know, all it's got to do is sit flat. So sit flat on the shredder dial. So even if this is tapered, it doesn't really matter as long as it sits flat on this surface here. So this surface has to be flat here, and there can't be anything protruding here or any sort of blow down over here. So that has to be ground off or filed off or chiseled off or whatever. So that's the only issue that there is on this. So it just has to be clean on these edges here. So I could also just bump this if I want more stability with having, you know, this being supporting the dial. I could just bump this up a little bit, you know. So go in here. Am I still in? No. Even 20. Even 20 thou is fine. It's gonna be thin here. Even that's fine. I still get a lot of stability. It's still okay. And then I can even fillet these edges so it doesn't even stop at these edges. So I go in here and fillet. Oops. So it just kind of rips around here. Just kind of rips around, so I think that would be fine. Anyways, that's pretty much, yeah, so I'm going to go through and check all of these and make sure that, you know, that it can, you know, meet the tolerances that I'm looking for, like these half moons. Those are, you know, low tolerance stuff. A lot of stuff is low tolerance. So, yeah. So I'm going to go through and make sure that the tolerances are something that they can hit, and anything that I could downgrade the tolerance of, or round edges, or make sure there's no square edges where this thing's got to stop. So this thing could just kind of rip around these square edges. So also I'm thinking fillet this guy so it could rip around that edge and not try to do a square edge. And even these guys have rounded edges, so it just rips around these edges here. So that is also a good idea. Yeah, so here's kind of the layout of the shredder here. And then this guy. Also, I need to drop the tolerance of this guy a little bit. So I think I'm just going to shrink it slightly and then open the square back up. So this is okay, this tolerance is okay, this tolerance is low tolerance again. This is pretty tight tolerance, and then I have to have the two bras. Pretty sure I designed it. Oh, right here. This is the bra that goes on top of this that the bearings get pressed into. Yeah. So we need two of those, 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 24 of those, 24 of those, 24 of those, and 2 of those. And that makes up the whole shredder. Okay, so let's go ahead and look for some, we could, I think we're pretty good right now on the general layout. I want to think a little bit more about, keep working on the feasibility of this project. Look at this hose that goes up and over. Obviously, we got a crap ton of water in here. I think it's going to be perfectly fine for our pump and the heat that we're going to put into it. So I think that's okay. So what I would like to look at is try to find some Arduino controlled backside of the pump, and then find some sort of blow off valve so we have that, and then tomorrow make some phone calls about how much the hose costs and how I would go about getting it, and then possibly order this guy. So then again, maybe not necessarily we'll see if we could use it, but use it's number one. Number two is if I'm not going to use it, I could sell it. But I do plan on using it to make the shredder to make a hairline cut, and also develop some ways of saving water, and eventually have it direct driven so you don't have the losses of the compressor and then pump and then compressing the water on top of each other, because that drastically increases the cost for electricity. So we'll see if we can even convert that pump to do that. We'll see. Maybe we could have some sort of instead of inside having a compressor, maybe we have another high pressure seal on one side, and basically move it. Well, let's see the internal workings of it in order to see if we can put like a shaft in there and have some sort of reciprocating motion, drive the pump. Or even we could, build our own with aluminum and multi-stage pump, and it goes in one stage and then second stage and pumps it out, and just take a block of aluminum and machine it, press some bearings in there, and put a crankshaft, make a crankshaft kind of thing, and or even like take a crankshaft off of a car motor or something, or find some sort of car motor and then basically build an aluminum block that's like the car motor, something like a 1.3 or something, a 1.3, or even use the car motor and use like aluminum block car motor or a motorcycle motor or something like that. A small motorcycle motor, 600cc motorcycle motor that's, I don't know, got bad oil galleys or something. And then we just rotate it. Instead of using that, we have a pulley on it, and we use the front pulley, and we remove all the valve. We actually technically have to keep the valve train, but in this case it's a 4-stroke, so we have to make our own cam and load our own cam in there. But this thing's going to be rotating way slower, so we don't have to worry about that as much. But we don't want to get any oil in it either. Oh. It'd be like, and then again, I don't think that a regular engine can handle this kind of pressure, so we'll probably need some sort of, maybe even we'll need a block of high density polyethylene or PTFE or ultra high molecular weight, polyethylene, and some seals, and then some plastic, and then machine it, and then have some aluminum pistons with some nice O-rings, high pressure O-rings, and use that to compress the water and pump it out and see how many stages and how many input pistons that we need and how big we could load onto the machine itself. Okay, grab my cat. All right, so let's see what we could find. There's for a welding machine. Air control tables. Oh, we don't want. .36 volts is pretty high. So we need this, and then we need a solenoid. Normally open. So, but we might want something just for failsafe normally closed. This 12 volt DC. We want DC definitely. Well, this could use SSR relay, but 12 volt we're gonna have to boost it. So either have a manual relay or I wonder if they're the same one but normally closed. Let's take a look at their website. This is a kind of higher quality one. I mean, we don't really need anything super crazy. It just has to be. Oh, even push connect. 110. So yeah, you just push the tubing in there. But 60 psi, can you do that? Oh, what about 1/4 inch? $10. Vinyl, not the greatest for the environment, but that's fine. Anyways, so yeah, probably something like this, but 1/4 inch nylon reinforced, hold it together, and then plastic. That's probably what we use, and then this got a quick disconnect. Quarter inch. Flow rate approximately 1.5 gallon per minute at 60 psi. Oh, but this is pressure, so I don't think that we need that much. 1.5 gallon per minute. Gallon of air. A gallon of air is really big. 60 psi. Dishwasher, dental tools, fish tank, beer brewing, hydroponics. There's a lot of water stuff, but I'm most likely going to use it for air as long as this thing doesn't leak. Water and air are two different things, but I think that this is pretty nice. Go ahead and add that. I like this one. Okay, so we can either go 110 or 120, but we ask them for that's the 120. Tiger, you get too hot. Okay. So that's one part. Now we need some sort of, let's see if they have a solenoid. 3-way valves. Ah, that's what I'm talking about. But these are going to have to, so I was thinking maybe I could get rid of the other one, but I can't because this does have to have this piece here. The only other way, there is no other way really. So we have to cut the power and then we have to blow it. CV, I think, is something with the turbulence, so loss in pressure. So that's really good. I like that. Do they have any here? Okay, so this is definitely good. So they're all about the same. I want 1/8. That's way too small. So let's save this. In the grand scheme of things, $36 is nothing compared to the rest of the project. But I mean, still, I would like a plastic valve. I mean, we're not doing some crazy high pressure stuff. Just 60 psi. That's half the rating. That's half the pressure range, and hopefully this has got a safety factor on top of it. But this is perfect. It's even refers to it as exhaust port. Okay, so valve de-energized. Okay, so yeah, so we want that other one normally open. Actually, no. Yeah, we want it normally. Oh, the valve is normally open, normally closed. Is that what that said? Oh, I think that this is like a special. I think they're all mainly normally closed. I think that's why it says normally open there. Yeah, so I think the rest of these are normally closed. Okay. So yeah, 6 watts. Normally closed operating position. Okay, perfect. $16. So the other one's about double the price. Maybe we could even upgrade to brass just to make sure that it lasts longer. I really don't think it matters. Let's see. Stainless, we're using air, so. $25. There's $7. Normally close operating position. Valve will open when energized. Perfect. So open when energized, and then this other one. So basically what I'm going to have to do with this is I'm going to have to cover this. Oops. So basically I'm going to have to cover this thing so when or build a silencer so when it fires, it doesn't blow your eardrums out when it fires. Because it's going to be blowing 60 psi pretty much instantly. We want it like that, so we want it to go really, really fast, so it's got to dissipate all that energy extremely quickly. So we need it to get rid of that energy instantaneously. So we need to work on that, and then obviously 12 volt. Just use a regular relay on, and then basically we could have it so both of them open, both of them close, so we could have them both on the same relay because both of normally so when it's energized, let's go down here, de-energized. Perfect. So this is like normally open, or I guess you could say exhausting without energy, which is the same as the other one. Without energy it's closed, and with energy it's open. So that would be perfect. We can put it all on one relay and run the relay. Actually, I think they have a spindle set up. I think they have output for spindle here, I think. because there's 12 to 36 volts in. So there should be some sort of signal. Spindle engage. I wonder if it does 12 volt. We'll have to see. It might do 12 volt right for spindle engage, and it might be able to drive this. I mean, it says it's 13 watt. Oh, that's 1 amp. And the other one is, this is similar, so 6.6. What about this one? 18 watt. Okay, so 18 watt, 1.5 amps. So yeah, might use a relay, have it drive a relay. It's not a problem, relay. I have a whole bunch downstairs, so that's not an issue. So I think we've found it, and I think we're good to go in that area. So I should try, I'm going to try again to talk to these guys in the morning and see if we can find hosing. And then we'll be good to go, and we'll have to buy this guy, and then buy the tank, and then build the tank, and then get the hosing, and then get these parts, and then do some testing with the gerbil, and just get the thing and hold it in my hand and fire it with the pump. Oh, and then we need to make the manifold for the pump. That's another thing. So. Alright, so this has been Steven from Legit Tech Tutorials and the Green Engineers. I'd like to thank you guys for watching. If you like this video, please subscribe for more videos like it, and I'll see you guys next video. Take it easy. Peace.